Okay, so I'm going to be making a video on how to solve number 2 from today's assignment. A 50 Newton force is pushing horizontally in a 10 kilogram box. The coefficient of static friction between the floor and the box is 0.43. And if the coefficient of kinetic friction between the box and the floor is 0.25, assuming that you keep the same pushing force, what will the box's acceleration be, and what force is needed to keep the box going at a constant velocity? Okay. So let's start with just a simple picture. Oopsies. Let's just start with a simple picture here. We've got a 50 Newton force pushing this way. This is 10 kilograms. The coefficient of static friction is 0.43, and the coefficient of kinetic friction is 0.25. So static is 0.43. Mu sub k is equal to 0.25. And again, I want to point out, this was in your notes, but notice how the static frictional coefficient is higher than the kinetic coefficient. That's because things always have more friction when they're not moving. For example, if you're trying to get a really heavy chest, you're trying to slide it across the carpet, it's really hard to get it going, but once you get it going, it's easier to keep it going because the friction drops as soon as the objects are sliding. When they're just sitting there, the friction is more. So anyways, it's asking for what the box's acceleration will be. So the first thing we got to do is figure out, is this box even going to move? So let's just take a peek at its frictional coefficient. Let's just take a look at the forces that are applied. You have a 50 Newton force going this way, and let's take a look at the static frictional force. So the static frictional force is going to be mu times the normal force. And in this case, the mu is 0.43, and the normal force of this object, I'll do this in blue. So if this is mg going down, the normal force is the supporting force, and in this case, the normal force has to equal mg because the object is not moving up and it's not moving down. So the normal force and mg have to be equal. They have to cancel each other out. So m was 10, g is 9.8, and so we're going 10 times 9.8 times 0.43, 42 point, I can't really tell what that is. It's 42 point something. My calculator has a bad pixel on it, so it's hard to tell, but it's less than the 50 Newton force. So yeah, this thing's gonna move. So we got to figure out what's the acceleration, because the pushing force is greater than the static frictional force. Okay, so the first thing to remember is F net equals ma. Net means total. We have two forces going on here. We have here, I'll just draw it again. We have the pushing force this way, and we have the static frictional force, or we have the kinetic frictional force this way. So F net is the total of those two forces. And remember that one of them is going in a negative direction. That's this one right here. This one's going in a negative direction. So we just got to be a little careful there. So here we're going to say 50 newtons plus a negative force of friction, which we haven't calculated quite yet, is going to equal the ma of the box. Okay, so the force of friction right here is not going to be that hard to get. It's mu sub k times the normal force. Again, it's the kinetic frictional coefficient because it's sliding. Because we know it's sliding because there's not enough static friction to keep it still. Okay. So the frictional force is going to be 0.25 times m times g for the same reason I mentioned before, that the normal force is mg on a flat surface. So 0.25 times 10 times 9.8, 24.5. Okay, now we're on to something. Remember, this number is the frictional force. So now you have 50 newtons of force, it's being opposed by a negative 24.5 newtons of force. The net result of this is MA. We already said that the M was 10, and A is what we're trying to figure out. So you can see right now, it's just literally just, 7th grade algebra at this point. So 50 minus 24.5, that's going to be 25.5. So 25.5 divided by 10 equals A. So A is 2.55 meters per second squared. All right. So that's that will be the acceleration of the box. Again, the key here is that F net equals ma, and the net force was the combination of these two forces, but one of them was opposing the other one. That's why we have to have a negative sign on it. Okay, so back to what we were doing. What force is needed to keep the box at a constant velocity? Okay. The key, whenever you see the terms constant velocity, that is 100% the key. You have to catch that term. If you have a constant velocity, that means that the acceleration is 0. All right? So the acceleration is 0, meaning if F equals ma, I'm going to go back to here for a second. If the acceleration is 0, that means that the net force has to be 0. Right, because any number of times, any mass that has 0 acceleration has 0 net forces on it. Okay, so the net force on this box, I'm going to draw it again real quickly. So we don't know what the force is in this case. This is the force of friction here. The thing that we do know is that these two forces have to cancel. So you can think of it this way, that F plus F sub F have to equal 0. Another way of saying that is that just whatever the value of F is, that has to equal these two forces in magnitude, and the amount have to cancel each other out. Yeah, we know that this technically is going to be a negative sign, but what we're talking about now is just the amount or the magnitude. If it's 50 newtons this way, it's got to be 50 newtons this way, and that's what I mean. Again, in physics, you can drop negative signs if you understand the physics and if you understand what's happening. So we need these two forces to cancel each other out, because that is the only way you'll get an acceleration of 0, which is the definition of constant velocity. So, what force is needed? Well, we better set the force of the push equal to the frictional force, and we already said that the frictional force was 24.5. So, if the frictional force is 24.5, in order to keep this thing going at a constant velocity, your push better be 24.5 newtons. And that is how we do number 2. I will pause for your applause. Okay.